Hi! Before we start, I would like you to imagine, have you ever played a game of Pictionary? You think you have drawn a masterpiece of a horse, but your teammates are shouting that it looks like a burnt potato or a crab with legs. It's funny, right? But it's a total nightmare when you try to explain something important and all you see are blank stares because your drawing just doesn't make sense. That leads me to talk about PFD mastery, the blueprint of chemical engineering thinking today. Hello everyone, my name is Faiqah Binti Zulkurnain. My matrix number is A201015 from set 46. As a chemical engineering students, we have all worked with PFD, process flow diagram, in our assignments and project. A PFD is basically a diagram that shows the main equipment and how material flow through a process. And that's why we engineers rely on it to communicate process ideas clearly. As a third year myself, I have experienced to draw a PFDs in each semester for our integrated project IP and experienced repeated feedback from the lecturers, which made me realize that mastering PFDs is still challenging for many of us. Today, I want to talk about mastering PFD is actually matters for us as students and not just for passing assignment. So, I will discuss what are the problems that we face when working with PFDs. Then, I will share a practical solution that we can do and why mastering PFDs benefit us as a future engineering. To better understand why this issue needs attention, it is important to first look at the main problem involved. In general, developing a clear and accurate process flow diagram, PFD, can be challenging. To begin with, some of us struggle to fully understand meaning and function of standard symbol used in PFD. As a result, equipment such as pump, heat exchanger may be misinterpreted or placed incorrectly. Consequently, this leads to confusion when trying to explain the process flow or justify the design choices. Over time, this can reduce confidence when presenting the diagram. In addition, symbol interpretation, another major issue is weak connection between PFDs and engineering calculation. Although calculations such as mass balance and energy balance we perform, they are often not clearly reflected in the diagram. Because of this, the PFD appears disconnected from the actual design data. Therefore, it becomes difficult to show how calculated values support the overall process design. Moreover, limited access to professional diagram software further complicates the process. This is because some of the software we need to buy to get access. Without proper tools, diagrams are often drawn using basic platforms that lack standard symbols and formatting. This limitation can also slow down the design process and reduce overall clarity. Essentially, these mistakes make our technical work look unprofessional and difficult to follow. Since the problem can significantly affect the quality of PFDs, and a practical solution is needed to reduce these difficulties. So, here is a simple and practical way for us to mastering process flow diagram, we should do more article reading. Engineering articles often include real examples of PFDs used in industry, which help us understand how symbol and flows represent actual equipment and processes. By reading this, we can see how PFD used beyond coursework and making diagrams easier for us to interpret and apply it. Reading articles help connect the theoretical knowledge with practical application. All those articles explain the role of PFDs in process design, safety analysis, and optimization, that actually allowing us to understand clearly. When we see how professionals describe the PFD, automatically we learn how to read and create diagram more effectively. Definitely, this is suitable for us in terms of time and cost. Many engineering articles are freely available through journals or even open access publication in Google Scholar, for example. So we can read it without us worry to download or buy any other additional software. By using these free resources, we can teach ourselves to design like professionals. When improving the understanding of PFDs, it will provide us many benefits. Firstly, a well-constructed PFD helps us understanding how the flows from start to the end of the process. This clarity makes it easier for us to explain each unit operation without constantly referring back to calculation. As a result, discussion becomes another smoother and more focused. Secondly, integrating calculations properly into the PFD help us to bridge the gap between theoretical knowledge and practical design. When values such as flow rates and energy requirements are reflected in the diagram, the process that we do become more realistic. So this connection helps us see how calculations actually influence engineering decision. Better communication and confidence. Finally, clear and professional PFD improve our communication during the presentation, also while discussion. It allows us to give more ideas and explain because the diagram itself support what is being said in the long run, which this confidence encourage better understanding and collaboration. In short, a clear PFD make you a more convincing and skilled engineering student. Now that we have looked at the problems, solutions, and benefit, it is clear why this issue should be mastered. To summarize, the main problem include unfamiliarity with PFD symbols, weak integration with calculations, and limited access to proper tools has been discussed. By us addressing three issues, the overall quality and clarity of process flow diagram can be significantly improved. So instead of us rushing to do the PFD, take a bit more time to look at related articles and understanding why things are grown a certain way. Small efforts like this can make a big difference and how clear the convincing your PFDs are. In the end, process flow diagram is not just a drawing, but a way to clearly tell the story behind the engineering process. I think that's all from me. Thank you.